So data mining is the exploration and analysis of large data to discover meaningful patterns and rules. And it's considered a discipline under the data science field to study and differs from predictive analytics because it describes historical data, while data mining aims to predict future outcomes. So this particular data mining works on very past data, very historical data, and it deals with a huge amount of data. Additionally, data mining techniques are used to build the machine learning models that power modern artificial intelligence AI applications such as the search engine algorithms and recommendation systems. So here is the main application of our data mining. So business world generate gigantic amount of data sets, including the sales transactions, stock trading records. We're going to have these product descriptions, we're going to have the sales promotions, and then company profile, and then performances, and then customer feedback. And you can also have our data generated by different sensors. It is not like that always will be having data from the web. So here we are having the stock trading, we are having the product descriptions, sales promotions, performances, that is the company profiles and performances, and customer feedback, and also will be having data generated from different non-web sources. For example, a large store, say such as say Walmart, handle hundreds of millions of transactions per week at thousands of branches around the world. The scientific and engineering practices generate high orders of data, there is a petabytes of data, and in a continuous manner. And when remote sensing, process measuring, scientific experiments, system performance, engineering observations, environment surveillance, so in multiple different sources we shall be having our data mining. Here this data mining will be dealing with huge amount of historical data, and it is mainly required for the recommendation systems, for the search engine algorithms, and so on. So data mining turns a large collection of data, into a knowledge. So that is the main purpose of our data mining. So if you ask me that what are the applications of data mining, if you ask me, then I can say that data mining can be used for say database marketing, credit risk management. It can be used for say training and support. It can be used for product product development. Also we are getting the guidance from the past data, the product development, fraud detection, healthcare, and the bioinformatics. We can also go for sentiment analysis, we can go for spam filtering, and also we can use this qualitative data mining. So there are multiple different applications where this data mining can be used. Let us discuss the basic architecture of data mining. So at first we are having the users. These users will be accessing multiple GUI interfaces, that is a graphics user interface, or they might be having some web applications. Say one user is trying to get a product, say on a book on say artificial intelligence from the Flipkart. So that user will produce some requests, and through the user interface the request will be available to the next phase. Here the pattern will be evaluated. What is the meaning of the pattern? Pattern means say I want to purchase one phone, mobile phone, having got a price say in between 10 to 20,000. I want to purchase a mobile phone of a certain company. So that would be my pattern. I want to purchase one artificial intelligence ebook from this Flipkart, or say from say Amazon. So that will be the pattern. I can also mention the author's name, I can mention the price range. So everything will be considered as a pattern. This pattern will be evaluated. So then it will be coming to this data mining engine. This data mining engine is a very smart one. Here all the association rules and relations and clusterings will be done here. So this data mining engine will be now communicating with this database or data warehouse server. This data warehouse server is nothing but it will get the request from this data mining engine, and then from there it will just go and fetch the required data from different data sources after doing the data cleansing, data selection, data integration, data aggregation, and so on. So here the multiple data sources might be there. It might be the database, might be the data warehouse, which is actually containing multiple different heterogeneous type of database in a single place. We may have some world wide web, and from some other repositories the data will be accessed and the data will be cleaned, the data will be selected, the clustering, and then respective the data integration will be done, and then through this database and data warehouse server, so the data will be available to the data mining engine. So here actually the clustering will be done, the association rules will be applied. So say here it might be found that what is the pattern, what is the data association rules means actually, see, the main thing is that, so if we have seen, if we go through the data analytics through the shopping data, we are finding that whenever a person is purchasing one computer, he is also purchasing the operating system. So which is being purchased and which is being purchased along with that, so that will be decided by the association rules and relations and clustering. So this particular data pattern evaluation will be done, and respectively the output will be obtained to the user through this user interface. So if this user wants to do the same searching once again, that the respective search result will be kept in this knowledge base. So instantly from the knowledge base, the search output will be made available to the user through this user interface. So we know that data mining refers to extracting knowledge from large amount of data, and that is actually our data mining. So this basic architecture has indicated that what are the different phases in which the data mining operations used to take place. We are discussing what is the data explosion problem. A tremendous amount of data being continuously controlled and warehoused. You know that warehouse is nothing but heterogeneous databases residing or storing at the same place. So it will be the web data, the e-commerce data, the sensor data, offline data. There are so many different kinds of data will be there, and purchases at department, grocery stores, and the bank and credit card transactions. So that will create gigantic amount of tremendous amount of data. So need a way to extract information out of this large data. So depending upon the user's query, depending upon the pattern of the data, the query has to be answered, and also the respective notifications, suggestions for the decision making will be obtained from this data mining. And the solution here is that the data warehousing and online analytical processing, an extraction of interesting knowledge like rules, the regularities, the pattern in the data, some constraints from the data in large databases. So these are the interesting knowledges will be obtained through this data mining. Now data warehouse and OLAP. What is the full form of this OLAP? OLAP is having the full form, that is your online analytical processing. So one emerging data repository architecture is the data warehouse, and this is a repository of multiple heterogeneous data sources organized under a unified schema at a single site to facilitate management decisions. So user will ask for certain type of decisions from the data mining system, and after exploring through this huge amount of data, the decisions will be obtained, and not only the decisions, along with some other suggestions will be obtained to this respective user. And data warehouse technology includes the data cleaning, the subject orientation, non-volatile, time variant, data integration, and online analytical processing, that is the analysis techniques with functionalities such as summarization, consolidation, aggregation, as well as the ability to view the information from different angles. So you know that sometimes we want to know the data, sometimes we do not want to know the actual data, but I want to get the summarization. I want to get some aggregated output. I want to get some, say, maximum value, minimum value, variance, kurtosis, skewness. We can also go for median, we can also go for mode, and in this way I want to get the average. All these things will be known as the aggregation. I want to get some summary of my data. I want to get the descriptive statistics of my data. I want to merge multiple different data to get the consolidated report. So everything must be there in our OLAP, and this OLAP will have mainly the 4 operations. What are they? So there is a drill down, roll up, dice, slice, and pivot. So these are the operations are there. We can also consider this one as a 4 or 5 operations we can also go. In case of drill down, I do not want to see only the respective sales report for the year 2020. I want to see the sales report for 2020 for a certain country, say Philippines. I want to see not only the Philippines but also the respective product, certain number of products against the country Philippines for the year 2020. So I want to get the sales report into more details. So that is known as the drill in, that is a drill down. And if you go for the macroscopic view, then you are going for OLAP. If you go for the microscopic view, that is known as a drill down. And getting data from multiple different sources, multiple different types of databases, whenever you are putting those data a side by side columnar way, so that is known as dicing. You can slice it. You do not want to see whole part of the data, but for a certain filtering you want to do, so that is known as slicing. And you can make some of the attributes group by, and then against that particular group you want to see the other aggregated results on some other attributes, and that is known as a pivot and unpivot and so on. So these are the OLAP main operations, that is drill down, roll up, dice, slice and pivot. So these are the operations, main operations for this OLAP. So in this video we have discussed what is the data mining, the definition has been given, different terminologies, architecture of the data mining, and we have completed the introduction to data mining. Thanks for watching this. Let us discuss types of data mining models and tasks. So there are two types are there. For this data mining. The first type will be known as predictive. The first type is known as the predictive type, and the second type is known as descriptive. So here in case of predictive, obviously from the term is very obvious that we'll be going for predictions, we'll be going for forecasting, and here the prediction will be the one of the tasks as a subtask for this predictive type of data mining. We can also go for the classification. We know that the output may have multiple different classes. For a new set of data, what will be the class of that particular data, so set or in the data pattern, so that will be obtained. We can also go for regression, and you can analyze our data against time in time series analysis. So next one is there is a descriptive data mining. So here we can go for the clustering of the similar type of data depending upon the data pattern observed. Summarization, that means we are going for not for the individual values but for some aggregated values by the summary values. Association rules, that which are the items, which are the data are associated between each other, which is the antecedent, which is the consequent. So there is the association rules. And the sequence discovery, that means that's how this pattern will have a certain sequence to observe. Now here we are discussing that what are the 6 different steps involved for the accepted data mining processes. The 6 processes are there in our accepted data mining. So first one is there is a business understanding. First one is my business understanding. So it is actually establishing the goals of the project and how the data mining can help you to reach the respective goal, and that is a business understanding. A plan should be developed at this stage to include the timelines, actions, roles and assignments. The next step will be our data understanding. Data is collected from all different applications and data sources will be there in its own step. Data visualization tools are often used to in this particular stage to explore the properties of the data to ensure whether it will help achieve the business goals or not. So different kinds of data visualizations are possible. We can have the different types of categories are there. So we should select that very category of data visualization technique with the help of which we can easily get the idea whether it will help me to reach to our business goals or not. Next one is our data preparation. So it is a very important one. So next phase is our data preparation. So data is then cleansed and the missing data is included to ensure it is ready to be mined, and the data processing can take enormous amount of time depending on the amount of data analyzed and the number of data sources. So therefore distributed systems are used in modern database management system, also known as DBMS, to improve the speed of data mining process rather than burden a single system there. So there are also more secure than having all an organization's data in a single data warehouse. So it is important to include there is a safe measures, I think, and in the data manipulation stage, so that the data is not going to get permanently lost. So that is my data preparation. Next one is about data modeling. So mathematical models are then used to find the patterns in the data using sophisticated data tools. Next one is about evaluation. The findings are evaluated and compared to the business objectives to determine if they should be deployed across the organization. Last one is about deployment. So in this final stage, the data mining findings are shared across everybody everyday business operations, and an enterprise business intelligence platform can be used to provide a single source of the truth for the self-service data discovery, and that is known as our deployment. Now we're going to discuss that is the benefits of data mining. So far I have seen that there are 4 different benefits are there. So it is the point number 1. So point number 1 is about automated decision making. So data mining allows organizations to continually analyze the data and automate both routine and critical decisions without the delay of human judgment. And banks are instantly detect fraudulent transactions, request verifications, and even secure personal information to protect customers against identity theft. And deployed within a firm's operational algorithms, these models can collect, analyze, and act on data independently, so that the streamlined decision making and enhance the daily processes of an organization, and that is known as automated decision making. The next one which we want to discuss, there is a point number 2, is about accurate prediction and forecasting. So planning is a very critical process within every organization, and data mining facilitates the planning and provides the managers with reliable forecasts based on the past trends. That means what are the data pattern we observe in the past and current conditions. And in this way, the accurate predictions and forecasting will help the respective to take the business decisions by the business managers. Next one is a very important one, that is known as the cost reduction. So this is my point number 3, cost reduction. So in case of cost reduction, data mining allows for more efficient use and allocation of resources. So organizations can plan and make automated decisions with accurate forecasts, and that will result in maximum cost reduction. Last one, that is the benefits of data mining. The last point is our customer insights. So I'm making this one as point number 4, customer insights. So firms deploy data mining models for customer data to uncover key characteristics and difference among their customers, and data mining can be used to create the personalized each touch point to improve the overall the customer experience. So customer will remain happy because they'll be getting their customized outputs according to their customized needs, and that is the customer insights. So here we have discussed that there are 4 different benefits of our data mining. Next one we're going to discuss, that is our KDD process. So KDD process. So what is the KDD process? So the term KDD stands for knowledge discovery in database. It refers to the broad procedure of discovering knowledge in data and emphasizes the high-level applications of specific data mining techniques. So KDD stands for knowledge discovery in database. So let us go for some more points, that is the problem formulation, the data collection, subset data, there is a sampling might hurt if highly skewed data, and feature selection, principal component analysis will be done, the heuristic search will be done, where the searching will be done with some prior knowledge, and then we'll be going for pre-processing and cleaning. So name address cleaning, different meaning, that is the annual, yearly, what is the different meaning of that, and duplicate removal, supplying missing values, detecting outliers, and detecting the noise factors. Next one is our transformation. Map complex objects, as example time series data, to features, that is frequency, and choosing mining tasks and mining method. So which mining task and which mining method has to be selected for this particular problem solving, for this particular the respective domain expertise. So that will be decided. And last one is our result evaluation and visualization of the data for more comprehensive way to represent our data in our data visualization mode, so that everyone can comprehend, everyone can draw inferences out of that. So in this session we have discussed that what are the different KDD processes can be applied in our data mining. Thanks for watching this video.